This is the third part of the D-Ring tutorial. In parts 1 and 2 we looked at creating the components shown in this assembly, and in this tutorial we're going to look at putting them together in the assembly itself. So the first thing that you may want to do, if you haven't already, is load the two parts into SolidWorks. So I'm going to open up the parts individually here. So there's the pin. I'm just hiding some of the detail on there that I've got shown, and I'm going to open up the ring portion as well. And again, I've got extra detail shown here to do with dimensions. I'm just hiding that. So you won't have the assembly, but if you've gone through the two tutorials, you will have the parts. So generally, when you're creating a new assembly, the first part that you put in, you will fix in position, and then all the subsequent parts that you bring in after that, you may want to use that original part as a reference on how to position all those other parts. So in this particular assembly, the part that we're going to put in first is the body of the D-ring here. So if you are looking at the part, if you've opened it up, there's a nice quick way to get into an assembly, and that is just on the file menu. There's a make assembly from part, and what that does is it takes the part that you're looking at, it creates a blank assembly space, which is what we're looking at here, and you can see it's pre-selected D-ring body for us. So if I was to just tick there now, you can see it's dropped the D-ring body. There's the D-ring body part in the feature tree, or the assembly tree as it is now. It's dropped it within a new assembly that is called assembly 2. Yours may call it something else, assembly 1. And that D-ring is now fixed in position within the assembly. I can't drag that D-ring. Now it's probably worth checking where it's put that D-ring in the assembly, because if we go up to the visibilities bar here and switch on the base planes, these are the base planes of the assembly. So just like when you're part modeling you get 3 base planes, in an assembly space you also get 3 base planes. So it would be wise in this particular instance to make the base planes of our part coincident with the base planes of the assembly. So it's worth just checking that that is what's happened. So if I roll over the base planes here, these are the assembly base planes, you can see them highlighting, and then if I open my part up here, you can see that I can view the features inside my part just by clicking on this arrow. And then I roll over the base planes of the part, you can see that yes, they are definitely coincident with each other. So let's just reverse there and quit out of that new assembly that we've just created. Let's say you didn't have the part open and you just come into SolidWorks and you wanted to create a brand new assembly. Well, you can do it this way. You can go File, New, and rather than creating a new part file, we're going to create a new assembly file. So I double clicked on assembly there, and again it's given me a blank assembly space here. And again, if I wanted to turn the planes on, I can here. These are the assembly planes, and that point where they all intersect is the assembly origin. And here on the left I have the documents that I currently have open in SolidWorks. So I can pick from here to put my first part in the assembly, or if I have no other documents open, I can browse on the hard disk and find documents that I'd like to put in this assembly. So in this case I already have the body of the D-ring open, so I'm going to click on that, and you can see that as I click on it, under my mouse pointer now is the D-ring body part, and as I move my mouse pointer around, it moves around the environment. If I was to click down somewhere here it's actually fixed that in space. I can't now drag that, and this is what this bracketed F in front of the part means. It means that the system has fixed it. Wherever I dropped it, it fixed it in that location. And you can see that that's not put it in a very wise location. It's not coincident with the assembly planes. You can see the assembly planes are over here. There's the front one, there's the right one, there's the top one, and my part planes are way over to the side here. So that's probably not the best way to place components if you want to know exactly where they are in relation to the assembly base planes. So I'm going to delete that. A far better way of putting the parts in, if you want to ensure that they're locked to the origin of the assembly rather than just some arbitrary point off here, is if you select them from this list like we did before, and you can see this is free to move now, and rather than simply clicking in the graphics window, if you click over here on this tick icon, you can see that as soon as I get near the tick, it chooses to put my component right in the center of the assembly. So it's locked my component origin or my component base planes so that they're coincident with the assembly base planes, which is a far wiser place to put your first component. So don't just click in the window here, because it will just drop it at wherever your pointer happens to be. Click over here in the green tick, and now you can see that it's put it coincident with the assembly planes, which is a far more useful place to have your first component. But it's also fixed it in position. You can see the F here, which means it's fixed. So that's our first component. I'm going to turn some of these planes off. I'm going to hide the primary planes, so those are the assembly primary planes, but I can still see the planes in my part file, so that's okay. So we're going to insert the next component. So insert component up here on the assembly tab gets me back into this dialog here, and again I already have the pin open in the background, so I can just select it from here, and again it's under my mouse pointer, and in this case I am just going to drop it in the window. But because this is not the first component anymore, this is the second component, the system chooses not to fix it in position. So if we look over here in the tree, you can see it does not have an F within those brackets. It has a little minus sign, which means it's unconstrained. It has a degree of freedom, and in this case it has 3 degrees of freedom because it can move in any one of the 3 directions. So if you look at the little triad down here, we've got the Y direction, the X direction, and the Z direction. This is free to move in all of them. So what we want to do is start locking that down, and I think we will hide all the planes because it makes it easier at this point. So we'll hide all the planes there. The first way that we're going to lock this down, if we just want to drag it a little bit closer to the part, is we're going to make the outside of this shaft coincident with the inside of these bars. So the easiest way to do this is if you click the shaft and then hold down the control key and click either one of these bars whilst holding down control, and then as I let go, we'll try that again, click both of these, as I let go I get this quick access toolbar, and we want to make these concentric. So there you go, it's made them concentric. So it's taken away one of the degrees of freedom of the pin. So there are other ways of adding assembly mates in here, and one of these ways of doing it is if you select the mate icon before you select any surfaces. So we click on that, and then this entry box is saying I want some entities in order to mate components together. So this is doing it kind of the other way. It's selecting the mate command first and then selecting the parts of your components that you want to mate together. So we want to put a mate between the end of the pin here and this surface on the D-ring. So as I click them, it's trying to put a coincident mate between them. You can see it's pre-selected coincident there. In this instance, I don't want them to be coincident. And by coincident, if you look at them there, you can see that they occupy the same plane. I want this pin to protrude slightly. So I'm going to pick distance. And when I pick distance, you can see it goes back to its original position, and then it tells me what distance it was originally away from this face. So I want it to be 2 mil beyond the face. So I enter 2 mil there. Now you can see that it is 2 mil away from this face, but it's in the wrong direction. It's 2 mil inwards, and I want it 2 mil beyond the face. So all I have to do is click flip dimension, and you can see it moved into the correct position. So it's gone 2 mil beyond the face. So I click OK there. I'm still in the mate dialog, which is fine, because I want to add some of the mates in now. I'll just temporarily quit out of there, just to show you that the only degree of freedom that this pin now has is the ability to rotate, which I want to take that degree of freedom away in this case. So I'm going to bring the planes back. So remember, we're not viewing the assembly planes here, we're just seeing the planes that are inside both parts. So if I rotate the pin, you can see the base planes of the pin rotating round. And what we want to do is we want to select the base plane that's in the pin. So in this case, I think that's the top plane in the pin, and I want to select the top plane in the D-ring as well. So I've held down Control and selected both of those items, and then I get the quick access toolbar. If for whatever reason I select both of those and then I move my mouse pointer and I lose the quick access toolbar, I can always click the mate icon up here. And again, what that's done is it's picked a default mate that it thinks I might want, coincident. That's fine in this case because they are coincident, but if I wanted a parallel relationship, which in this case will achieve exactly the same thing, then I can change the mate type there. If I wanted them at 90 degrees to each other, I could pick the perpendicular mate relationship, and you can see it's made the two planes, that plane there and that plane there, at 90 degrees to each other, or perpendicular. I can even put an angle on there. So the original position was 27 point something. If I wanted a 25 degree angle, I could enter that here, or a 25 degree angle in the opposite sense. And then if we come back out of the mate dialog, you can see that there's no bracketed minus sign in front of the pin anymore, which means the pin has now been fixed in position. It has no degrees of freedom. And likewise, the body still has the bracketed F, which means that has been fixed in position. So nothing in the assembly can move now.